Okay, let's look at these two graphs. Now, what do these two graphs have in common? Can you tell me one thing that these two graphs have in common? Well, if we look, this one is going up, up. So it's increasing. This graph is increasing. And yeah, so is this one. It's increasing. Okay, so it's going up. So they're both increasing. Let's write that. Okay, so they're both increasing, but obviously they're not the same graph. So imagine you were walking up this hill. Let's say this was a hill and you were walking up the hill or cycling up the hill. Does the steepness of the hill ever change? Does the steepness ever change? No, the hill is the same steepness all the way to the top. So it's never changing its steepness. It's never getting steeper or less steep. It's always the same. Now, if we look at this graph looks like, it actually looks like you have more than one graph in here. So it kind of looks like you have, like from this part, it looks almost flat. So it's almost flat from this part. So it's almost not even increasing at all. And then if you look at this part, it's increasing, but not quite that much. So this part is increasing, but not quite so much as the first part, as the last part. So here you're increasing, but not very fast. And then this last part, it looks like you're increasing really quickly. So here you have almost zero, almost constant, and then it's increasing a little bit slowly, and then really increasing. So here, if you're walking up this hill, at the beginning, it seems pretty easy. It seems pretty easy because it's almost flat. And then it starts to increase, so the steepness starts to increase. It's getting more and more difficult to walk up the hill. Then eventually it starts going really, really, really fast, really steep. Starts to get steeper really fast. So this is like an exponential graph. This is like a virus, for example. At the beginning, it looks like there's not many people who have the virus. Not many people have it. And then the numbers start to increase and increase, increase. And then more and more people have it, and then it increases a lot. So this is the curve that we're trying to avoid, right? So this is increasing at an increasing rate. Here it's increasing, but it's constant. The steepness is always the same. Whereas here it's a gradual increase. Okay, so here the increasing at a constant rate, and here it's increasing at an increasing rate. So that's a little confusing, but let's write it down. So in this graph, the steepness is constant, not the graph. Remember, a constant graph is horizontal. Here it's the steepness that's always the same. Whereas in this graph, the steepness is increasing. It's always increasing. So this is a good example of this would be the way a population grows, or the way a virus would spread. At the beginning it's slow and then it gets really, really quick. So that's a distinction between these two. It's a little subtle distinction, but it's important. So similarly, we could have two graphs that are decreasing. So this graph is decreasing, but again, the steepness is always the same. So if you're walking down this hill, it's always the same steepness. It never gets less steep or more steep. It's always the same. Whereas this graph, you're decreasing, you're going down, but it's very, very steep at the beginning, but then it gradually becomes less steep. So as we did before, you can do the same thing. You can say that over here it's very, very steep. It's going very, very steep. And then it's a little bit less steep over here at this part. And then at the end, it's almost flat. It's almost constant, this part over here. So this one is, they're both decreasing. This one, the steepness is always the same. And this one, the steepness is decreasing. The steepness is decreasing. So very steep, less steep, and almost flat over here.